So, hello everyone. Today we will solve the problem delete all occurrences of a given key in a doubly linked list. Okay, so you are given the head reference of a doubly linked list and you have a key. Okay, so your task is to delete all occurrences of the given key if it is present and return the new doubly linked list head, right? So you have an, for example, here you have an doubly linked list 2 2 10 8 4 2 5 2 and your key is 2. So you have to delete all the occurrences of 2, right? So here 2 is this 2 is deleted, then next this 2 is deleted, then this 2 is deleted and this 2 deleted. Then our new head is 10 8 4. So new head is 10 and we have to return 10 8 4 and 5, which is our new doubly linked list. Okay, and then next is for example this example 2, you have a doubly linked list like 9 1 3 4 5 1 8 4 and the key is 9. So you have to delete the, here 9 is also head, so you have to delete the 9. Okay, and the new linked list becomes 1 3 4 5 1 8 4. So all occurrences of 9 must be deleted in the new linked list. Okay, so the expected time complexity is big of n, and you have to you don't have to use any extra space. Okay, so we will see how to solve the problem. So first thing is, for example, you have linked list like doubly linked list like 1 2 3 and 4. Okay, this is doubly linked list, so it also have the previous pointer with next pointer null, and the head previous is pointing to the null. Okay, for example, key is 1. Okay, if key is 1, that is the head of the linked list, we have to delete. So what we will do in that case, first we will just move forward. That is, if our head is this, so we will do, we will write head is equals to head of next, and we will simply remove the head node. Okay, and we will return the head node, right? So this is the first case. The second case is if our element is in between the two nodes. So for example, the key is equals to 2 and we have to delete the node 2, right? So what we will do in that case, we will for example we will equate it as same. This is the previous one and this is the next one. So we will use the three pointers to traverse the entire link list. Means we are not going to use three pointers, but if it is in between, then we will use the three pointers. Okay. So for example, we have to delete the temp node. In that, what we will do, we will first equate the temp of next to the next node and previous node to the temp of previous, and then what we will do, previous node of next is equals to next node. If okay, it's n, we will take it as n. So what we will do, next node becomes temp of next and the previous becomes previous of n, and then what we will do, previous node next equals to temp of node, next of node, and next of node previous becomes the next node next n, that is next node previous becomes previous node, like right. So what we will do, our next node previous becomes pointing to this, and previous node next will pointing to this, and we will simply remove the temp node. Okay, we'll delete it, and again what we will do, and after that we will move our temp is equals to, we will move temp pointer to this. Okay, so we will see how we will solve this problem in code. Okay, so first what we will do, first we'll create the temporary node to traverse the entire doubly linked list. Okay, and we have to solve this in big of n. Okay, so we'll just traverse the doubly linked list once. Okay, so node star temp is equals to head reference. Okay, so as it is the pointer to pointer, so we will use one pointer to derefer it. Okay, so then next we'll use while loop. While temp is not equals to null, okay. So first, the very first thing we'll check if 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 our temp of data is equals to key. Okay, then what we will do, we will first check if it is head or not. Okay, if head reference, that is head reference, is equals to temp. If yes, head reference is equals to temp, in that case what we will do, head reference equals to head reference next. Okay, so this is what we will move our head reference to the one point next. Okay, after that what we will do, if it is not, for example, if it is in between node. Okay, if it is in between node, then what we will do, we will create two pointers. Okay, previous node and the next node. Okay, see, node star previous node, which is equals to, which are pointing to. So where this previous node is pointing, it is pointing to the temp of previous, and node star next node. So next node, that is temp of next, right? Temp of next. So next node is our temp of next, temp of. Okay. So next node is equals to temp of next, right? Then what we will do, for example, for example, the previous node, if it is null, and we are at head pointer, previous is null, and next is there may be any element. Okay, and we have to delete one. So first we need to check if it is null. If it is null, then there is no meaning to update its next and previous. Okay, so we first check it. If it is previous is null, then we doesn't do any operation. Okay, if it is there is a element, then we will update its next and next node previous. Okay, so we need to check. In the similar case, we also need to check if it is next is null. Okay, then we doesn't need to update its previous, and if the previous node is null, then we does not need to update its next. Okay, so we will write if previous node next is not equals to null, then we will only update its next. Okay, previous node, okay, sorry, it's a previous node only. Okay, previous node is not equals to null, then only we will update its next. Previous node next is equals to our next node, right? And if our next node is not equals to null, then only we will update its previous. Okay, next node previous is equals to previous node. Okay, okay. So now it's time to delete our temp node. Okay, so we'll delete our temp node. That is, we will we at that point we'll create, for example, you have linked list like 1, 2, and 3, and your key to delete is, for example, you have to delete uh, you have to, for example, you have to delete the second node. Okay, so first you are over here, and use first check is temp is equals to 2, and it returns true. Then you are over here. Then first we will check it is head or not. So it is not a head. So previous will over here, and our next is over here. Okay. Okay, we equate in this line previous node equals to temp of prev, and next node is equals to temp of next, right? Then we will check if it is not equals to null. Okay, this is not equals to null. Then what will happen? Previous of next is equals to next node. Previous node of next equals to next node, and the next node previous is equals to previous node. Okay, and after that we will delete this temp node. Okay, after deletion we want to traverse the entire linked list. Then we will equate next node, temp equals to next node, so our temp will move over here, and this will deleted, that is key 2 is deleted. Okay, so it will also works for if our previous is equals to null, or our if we add the end of the linked list, that is our next is null. Okay, you try to do by yourself. When what will happen when we are at the head of the linked list and our key is matching to head of the linked list, and if we are at the end of the linked list and our key is also 3. Okay, for example, our key is matching to the end of the linked list. Okay, so we'll delete temp. Now what we will do, temp is equals to, now we need to traverse entire linked list, so temp is equals to next node. Okay, and if it is not matching, in that case we will move our temp node, that is temporary pointer, to the next element, that is temp equals to temp of next. Okay, so we try to run the code, and as the there is nothing we have to return. Okay, so we'll try to run it. Okay, there is a problem. Key was not declared in this scope. Okay, X. There is a X. Okay, so it is working well. Now we will try to submit it. So okay, so it is submitted successfully. So if you found the video useful, like my video and subscribe my channel. Thank you.